Hello there and welcome back. My name is Michael Fudge. This is our Learn to Program in Java series. We're up to Lesson 20. Lesson 20 will kind of put everything we've learned so far together into a coherent program. We'll talk about some advanced programming topics like how you can use a service on the web and then consume that in Java. But in essence, we'll be taking all the lessons we've learned so far and kind of assembling them into one project. On the agenda for today, we'll look at using web APIs and services, and of course, putting it all together. The real beauty of the web is that many of your websites expose their services through APIs or application programming interfaces. You can use these APIs to build your applications around these services. Google Maps, Netflix, Yelp, Yahoo Finance, these are all examples of APIs that people use to build their own mobile applications or web applications. There's a great website called APIHub.com, and APIHub.com is a repository of APIs that are available on the web. For any given API, you can search for it, find the API, and read about it and figure out how to use it. For example, I'll go to the Yelp API website, and there's all this documentation about how to use the Yelp API. So if I want to build an application that maybe uses Yelp and Google Maps and superimposes Yelp information on a map, I can build my own website or build my own application to do that using both of those services. I don't have to start from scratch. Again, as we've learned and emphasized throughout the lessons that we've done in Java, is that the important thing about programming is reuse. And one of the big things about Java and all the other programming languages is that you do not need to reinvent the wheel. You can simply reuse the bits and pieces available to you that someone else has developed. So in our example for today, what we will do is we will take a look at this feed here from the USGS regarding earthquake data. And this particular feed has daily earthquakes of magnitude 2.5 or higher. And here's an example of the feed. So this is an Atom feed, which is a format of data. And this Atom feed is easily consumable by computer programs. And we will write something in Java that reads this Atom feed and populates this data into a collection of objects so that we can then do some basic informational analysis on that data. Of course, the data you're seeing right now will vary because this is real-time data. As the earthquakes are happening, this data feed is being updated. So by the time you run and use this example, your data will look different than mine. It's an important thing to note. So in our example, we will take a look at this data in Atom format, and we will parse it and populate a collection of objects, an array list of earthquakes. We will enumerate the collection, simply printing out a report of earthquakes. And hopefully we won't have too many problems, but if we do, we'll gracefully handle any exceptions. All right, let's get into the programming then. Okay, folks, here I am. I'm in my NetBeans IDE, and some of the code's been written. Some of it has not been written. I think I'll walk you through what I have written so far, and then we'll go through the real hard part of the program. So first and foremost, I have Quake Java. And Quake Java is a class that pretty much just holds my earthquake data. I have the date of the earthquake, the details of the earthquake, the location, the magnitude of the earthquake as a double, and then a link to some details about the earthquake. And you can see I have the constructor, which takes all those arguments, and then I have a bunch of getters where I can use to get the various properties that I've set. And there's no setter. The only way I can set the values is to create an object with the Quake constructor. So that's Quake Java. And then here I am in main Java, and in main Java I'm making an array list of quakes because remember, my feed is going to have a collection of earthquakes that have happened, all of 2.5 magnitude that happened today. And then I'm calling the getQuakes method, and I'm passing in the URL of the earthquake data. And then down here, this function, which is a method inside the main class, will simply, with that URL, return an array list of quakes. Once I get that array list of quakes, I'm going to print out a report header and then some date information. Then I'm going to print out the header of my table, which says when, lat, long, magnitude, etc. And then for each of my earthquakes, I'm going to print out the date, the location, the magnitude, and the details. And you see that down here. When, lat long, magnitude, details, and then all of the data. So I already ran it once before as when I implemented it, and then I erased out my code so that I can program the heart of this together. And what we need to do here in this logic is we need to take that URL, we need to go out into the web, we need to make a request, an HTTP request to that URL. We're going to get back a response, which is text. What we'll do with that response is treat it as a stream of data. With that stream of data, we will parse it as XML because the Atom feed is XML. And then we will enumerate over the XML, pulling out the elements we need from the XML. And in essence, once we have all the elements we need, we will then create an earthquake object and add it to our collection. I know that's a lot of details, so let's kind of get into it. And along the way, we'll talk about why we make some of the decisions that we do. Okay, first things first. Let's figure out how we can take that URL that we get here and read it as a stream. So when I'm all said and done, I'm going to have an array list of Quake. And I'm going to call this Quakes. And that's going to be a new array list, Quake. And then when the whole program's done, I'm going to return Quakes. But right now, of course, I don't have any earthquakes. What I'm going to do first is I'm going to need a URL. And I'm going to call this earthquake center URL. And that's going to be a new URL. And I'm going to use this URL. Right? So this represents, what I would type into my browser to get to the earthquake data. And then this is going to give me a reference to that. And this says malformed URL exception. So I need to catch that or throw it. I think I'll be lazy and, well, I'll try catch it. Let me do a try. Catch URL exception. EX. And for now, let's do a system out print F error %s EX. We'll do that for now. We'll just barf out the error. Correction, that should be a malformed URL exception. Like that. Okay. Now, what is a malformed URL? That is, if you have a web browser like this one here, you type in something that doesn't make any sense. Like this isn't a valid URL. It's got spaces in it and things like that. That's a bad URL. So that would throw a malformed URL exception. Now that I've got this URL, I can make a connection to it. Let's open up a connection to that URL. This is like connecting with your browser. This looks like it's going to throw in. This is going to throw an I/O exception, so I need to catch that. And we'll be lazy. That's fine. All right, moving on. Now that I've established my connection, I need to get an HTTP connection because you can have a URL to an FTP server or URL to other types of resources. So I want to say, and I need to cast this as HTTP connection. So I'm pretty much treating my connection as an HTTP connection. I think I need to cast that as the right type, Mike. That looks better. All right, we're getting there. So I need to see what the response is. Get response code. So this line here, line 38, what this is going to do is it's going to, when you establish a connection to a web server, it will return back a response. Like 404 means it could not find the resource. 200 means it found the resource and it was okay. So there's different response codes. A response code of 200 tells me something good happened. It means I made a connection and I got data. I'm getting data back. So I need to do this. I say if that response code, and I could say equals 200, but instead I'm going to say equals HTTP URL connection dot. And here are all the response codes. See 409, 408, 400, gone for 10. So I can keep looking. There's OK, and so you can response code 200 is OK. So if the response code is OK, then that means it's time to start looking at the body of the response, right? So I make, for example, let me show you here. I make a request up here to this URL that you see up here, and then in the response I see this data. Normally you would see HTML and it would draw real pretty things in your browser. However, this is a data feed, and this is designed to be consumed by a computer, as you can see. So you can see that this is, it says feed, and then there's a bunch of stuff, and then it has a title of the feed over here, and then it has one or more entries, and the entries have various keys and values that I can then parse, like, you know, the location of the earthquake, when it was updated, a link to more details about the earthquake. There's going to be a magnitude in here somewhere. If I look around hard enough, I can find it in this data. But I'm going to write a program that finds it in this data. My point about error code 200 is if I got some other response code when I hit this URL, I wouldn't see this data. So it's important to check for response code 200 before you look for the data, because a response code of anything other than OK means that you didn't get any data back from the web server. So if I fall into this if block, I have good data that I can then try to parse. So I'm going to use the input stream class for that. I'm going to get the input stream. All right. Need a Java I/O input stream import. All right. Now that I've got a handle to my input stream, I need to create objects that I can use to build out an XML parser. So if you look at this output from this data that I get, this is XML. It's got these brackety tag things, right? So I'm going to use an XML parser to help me kind of digest this data and structure it. It's unstructured. I need to structure it before I can figure out where the bits and pieces are that I need. You can see I'm using a lot of classes along the way, like document, builder, factory, DBF. If you look at all these classes I'm using, like document builder, factory, input stream, URL connection, you might be wondering, Mike, how do you know all of these? Well, I didn't. I had to look at a lot of examples online. I had to look at a lot of Java docs. For any one of these given things, you can go here and you can say show Java doc, and you can get all the details you need about the HTTP URL connection. You can learn all about how it works and how to put something together coherently so that you can make sense on how to use that class to your advantage in a program. And that's exactly what I did. And you know what? That's just how programming is. I'm reusing other people's stuff, all the things I'm highlighting, so that I don't have to do it myself. And you might be saying, well, boy, it seems like it would be easier to do it myself at this point because I don't know what this is and I don't know what that is. But you have to understand, it's much easier to learn how to drive a car than it is to learn how to engineer and build one yourself and then drive one, right? It's much easier to learn how to fly a plane than it is to learn how to engineer a plane and then build one and then fly one. So that's what we're talking about here. We're just using other people's stuff. This is completely acceptable in the programming world. I'm going to take advantage of it. So these classes and objects that I'm creating now, oh, this one throws another exception. This one throws a parser configuration exception. So I need to catch that. Now, normally I would not just catch these things like this. I would usually throw a better error on catch. But, you know, this works for now. I might say error, you know, you have a bad URL, and then print that, or error, you know, an I/O error occurred at this URL, or this one would say I unable to parse, you know, Atom feed or something like that. Okay, now that I've got my document builder and stuff, I can finally get to the point where I can make a document. Here's where I kind of glue it all together. I'm going to make a document called DOM, and I'm going to do a DB parse. And what am I going to parse? I'm going to parse my input stream. All right, so this is the magic, really, that kind of makes it all full together. This is going to throw another exception. SACS exception. Boy, I'm really loading up on the exceptions. This one is on SACS exception. So if you get tired of catching all these exceptions, you could just do this: catch exception. And why does this work to just catch a generic exception? This is never a good idea in programming. You should always catch the specific exception. But this works because all of these exceptions, as we learned before, inherit from this exception class. So these are all child classes of this class, which is why we can do that. Again, it's not a very good programming practice to do this, but it will certainly help me write this code a little more quickly, because now I'm just catching any old exception that gets thrown, and all of these are going to throw some kind of exception, and I'm just going to catch it here. All right, so I'm going to parse that input stream there into this document. And then now the document is going to consist of a... So next what I need to do is I need to get the elements in that document. So I need to say element doc element is dom dot get doc element. That gets me the document elements. You can see I'm importing all sorts of classes along the way, libraries. Then I could say node list doc element dot get element. I think I'll get element by tag name, and then I'm going to type in the word entry. And you're probably wondering, well, where is entry coming from, Mike? Where did you just get entry? You know, this gets me all the elements by tag name entry. So let's take a look at our XML again. Oh, there's entry. So I'm going to get all of the nodes with element entry. 1, 2. I'm going to get all these. Cool. Now what? Well, a little bit of checking. If node list is not null, which means we have entries, and node list get length is bigger than 0, so I'm just checking to make sure I've got an actual entry. What am I going to do? I'm going to say for int I is 0, I is less than node list get length I plus plus. This is going to be my main loop that iterates over each of these entries here. This loop is going to iterate over these entries. What am I going to do in here? Well, I'm going to start grabbing each of the entries and parsing out the values that I need. So rather than bore you with a lot of typing at this point, I'm going to copy and paste it in there and then describe what each piece is doing. Okay, so again, for each of these elements, I'm going to grab the first item in that element in this line. Then I'm going to find the title by going in that item and grabbing the tag name title, and then grabbing the first item in that title. So if we go back here again really quick, there's title. I'm going to grab this. And then the next time I'm going to grab that through the loop. All right, looking good. And then I'm going to find the tag Juris point, and I'm going to grab that item. That's going to be G. Then I'm going to grab the date here at up in the tag updated, and then I'm going to grab the link in the tag link. Then I'm going to go into the details, and I'm going to find the host name, and I'm going to build a link string from that because the link doesn't have the host name in it. Then I'm going to go through and find the date in here, and I'm going to parse out the latitude and longitude into a location down here. And then I'm going to get the magnitude by finding the space in the details and splitting that out. So let me go back and show you in the actual text here. So the magnitude is right here. See that? So I'm splitting here and then pulling this data out. And so you can see sometimes you have to do a little bit of crazy parsing to get the data that you want. And it's just kind of a side effect of semi-structured data. It's not perfectly structured the way I want, so I kind of have to munge this data up myself. So after I get down here, this is the last bit in here. At this point, I have a bunch of elements that I can use to finally make a quake. So I could say quake Q is new quake, and now I have my quake date, which I got right here, and I have the details, which I have here. I also have the location, which I got there. I have the magnitude, which I found there. And last but not least, the last thing I need to construct this is I need the string that links to the URL, which I got, which you can't really see, so I moved it up. There it is right there. So that has everything I need to build a quake. And now comes the easy part. I just added to my collection. Quakes. Well, it helps to spell it right. Quakes.add. Q. And there's my for loop. When this for loop is done, I will have a collection of quakes, and then I return that collection of quakes. And then in the main routine, I then use this for loop to print out the collection of quakes. Let me first run it to make sure it actually works. Then I will debug it so you can see how the parser is actually working. And I'm going to encourage you, of course, to run and debug this example yourself, step through it a line at a time so you can really see what's happening here. Okay, here goes. And there we have it. So when it happened, latitude, longitude, magnitude, and the details of the earthquake, including where it was located, Alaska, California, Mexico, etc. And if I go ahead and trace through this by hitting F7, and I drop into this array list here, I think what I want you to notice, I'm going to wait till I get down to the for loop. So my response code is 200, which is an OK, right? So I drop in here, get my input stream, my document is now a parsable. This is, barely coherent, but it's a in-memory representation of that parsed raw input stream. And then I can build out my node list. And then how many node lists do I have? Let's see, node list.length. What do we get here? There's 23 items in the list. See that? So I'm going to loop 23 times. Get these elements here. So let's see. Details are title, get first child node value. Details. See that? 2.7 km east of Soledad, California, right? So we keep going through here. Let's see where I parse the details down here. I'm going to go down a little further. So the first thing I do is I take the details and I split it at the dash. See that? I'm going to split it right there. So now details is 21 km east of Soledad, right? And one other thing I did was I had location pair 0, which is just some latitude and some longitude, and I use them to build location, which is a string that says lat and longitude. See that there? So you can see I built exactly what my object needed from the data that I had. And honestly, this is what took me the longest, was figuring out how to parse this stuff and parsing out the dates. I had to do that, parse the date time formats and stuff like that. So after this loop, you'll see if I hit F8, it just keeps going through the loop again and again and again. And then eventually, if I just keep running it, I will end up back outside of Get Quakes, and now I have a collection of earthquakes. And if I look at this, you'll see that there's 23 earthquakes in here, and I can look at any one of these and I can get a latitude, a longitude, and a location, etc. And then I'm just taking that data and I'm building out my table header, and then I'm running a for loop over my collection, putting it out. And that's really kind of the advantage of when you parse the data, putting it in a format that's familiar to you, because then it makes it much easier for you to do other things on it. I could tell you which one of these was the highest earthquake, the highest magnitude earthquake, much easier this way than trying to parse that information out of the raw source data. Well, that was quite the adventure, wasn't it? I encourage you to download this example and run it for yourself. Set a couple of breakpoints and trace through it a line at a time so you can really see what's happening. This is probably the best way to learn this type of stuff, is to look at other people's code, read other people's code, run other people's code, and kind of go through it a line at a time so you can really see what's happening. Well, thank you so much for watching. Again, if you have questions, comments, or just want to leave some feedback, feel free to post it on YouTube. Thank you very much, and goodbye now.